Welcome on this new video clip on big data. You should have watched before the video on the definitions related to data. In this video clip, we will give a basic definition of big data. Of course, we'll spend the rest of the course and the lectures discussing how big data is relevant to business. This video clip is just to give you the basic principles of what big data is about. So, the consensus today, I would say, is that there is no clear agreed upon definition for big data. I particularly like this very small message by Dan Ariely, who is an economist from Duke University. He said it like that: big data is like teenage sex. Everyone talks about it, nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they are doing it. So it's funny, but it's quite true. Big data is basically a concept that is being evolving as we speak, with no real, consensual definition. This said, I will try in this video to give you a sense in 5 points of what big data relates to. The first one is that, no surprise, big data is about data in bigger volumes, and I would suggest, of course, that the digitalization of the economy is a big factor that brought big data in the last 10 to 15 years. A simple example will show you how the digitalization of the economy actually generates bigger amounts of data just by itself. Imagine that you go to a movie. Without a digital experience, you would go to a movie theater, and basically the data it generates is quite slim. You basically buy a ticket at the box office, and on this ticket you will find the following data: the movie title, the date and the time when you bought the ticket for the movie, and the price. This is the only data that is generated and which is going to be saved in a system if the theater has such a system. Now compare that to the same action, watching a movie, but in a digital economy. So imagine you use Netflix for that. The data which is generated starts at the login. When you log into, when you create an account and log into to Netflix. I didn't do it myself, but I would imagine that for any, just like for any online service, you would have your name, maybe your age, your gender, maybe an indication of your geographical address, and maybe some questions about your movie preferences. But then it doesn't stop here, right? When you are on Netflix, again, I didn't practice it, but I would imagine that you can browse the catalog of movies, the ones that are actually being displayed in the cinemas, but the ones that were released a couple of months or years ago. Every browsing you do on Netflix is registered, is saved in the systems of Netflix, and they can use that to know better what are your tastes. Then of course, when you pick a movie to watch it, it generates more data. Netflix saves the movie title, the price that you picked it for, the time of the day when you picked it, and maybe also the time when you actually watch it. You can maybe buy it at some time and watch it later. Again, I'm not sure how it works, but it's possible that Netflix or a similar service would also get data generated on how do you watch the movie. Do you pause it? Do you watch it until the end? These kind of things. It continues with the ratings that you might also write, the reviews, the comments that you might write on the Netflix website. So you have a very fine feedback on the quality on your experience as a moviegoer. Still more, maybe again that might not be the Netflix experience, might be the case or another service, but you might follow movie stars or friends. So all this following activity, who is a friend with whom, who is following whom, is also data. And finally, it might or might not be the case, but imagine that if you have a Netflix account and you are suggested to connect it with any other of your accounts, such as your Facebook account or your Twitter account, more data is generated, because in this case, whatever you wrote down for your Netflix account can be compared and matched and completed with data coming from your other accounts that you just connected with your Netflix account. So I hope this example shows that the digitalization of the economy has been a big impulsion for the development of larger volumes of data being created, stored, and of course analyzed. The second fact that made big data a reality, or which developed the creation, storing, and analysis of data in bigger volumes, is that it became cheaper to do so. So what are the main areas where cost was a bottleneck? The first one was storage. I remember from the 90s when my parents bought their first desktop computer, we had on the computer a bit more than 400 megabytes on the hard drive, and it cost, the whole computer cost more than, so in dollars it would be, yeah, it would be more than $2,000, I would say, and about 1,500 euros. So for this price, in the 90s, you just had less than a memory stick in terms of storage. Today, for this price, well, you would have several terabytes of storage. And it's not just from the 90s to today. Actually, it's a continuing trend that every couple of years, the price for storage is cut by a factor of 2. This enables big data, right? Because now you can store it without being a billionaire. The second area where big data could not develop was that to transport data from one point to another, you couldn't, right? Either because the infrastructure did not exist. If you just had modems with a very low bandwidth, it would have taken days to actually download a movie, and it would have been quite costly because days of connections was even 10 years ago or 15 years ago quite expensive. Nowadays you can download gigabytes and even terabytes of data in a matter of seconds, minutes or hours for terabytes, and for a cost that is very low. Again, that's something that happened quite recently, and this enabled the generation and use and transportation of data well, from one point of the globe to another. And finally, even if you had cheap storage capacity and cheap broadband communication to actually get your data from a website to another or to your personal computer, you still had until 10 to 15 years ago the issue that the software that you would need to make something of this data, to analyze it, this software was still very, very expensive, in the sense that it was, most of it was I won't be able to pronounce this word, was private. The software were private and cost very large fees, with big vendors such as Microsoft and Oracle being the major and only big players that you could use software from. But for 10 to 15 years now, the open source movement developed software and programming solutions that are free to use. So the open source movement, just to make a brief parenthesis, the open source movement is the thing that made people create and share software and creations from their intellect for free and free to use. Again, this is something that gave big data a chance to happen, because now not just the few big players, but many small and medium enterprises could analyze the huge amounts of data they were collecting. The third point that, and I would like to insist on this one because it might be less obvious, the third point that made big data a reality is that it happened a conceptual shift on what data is. So to caricature a bit, but to give you a sense of what I mean by that, let's imagine what data is in the 90s and even the 2000s, and actually sometimes still today, but that's really something from the 90s. Data, in a traditional sense, was basically what administrations were collecting about you. So address, amounts such as your bank account balance, or credit rating, or date of birth, or the products that you purchased, if the data is the data from a store. This is data that everybody would recognize. Oh yes, that's the usual data that administrations and companies store about me. But as you are well aware, since 5 to 10 years now, data has received a larger, a broader definition. Now clicks on web pages can count as data because they are just interesting to analyze. But not just clicks. I would insist that any data about the localization of a person counts as data, whereas 15 to 20 years before it could have been discarded as merely technical details not worth storing or analyzing. All the information about networks, who's connected with whom, or who speaks with whom, or who has similar tastes with whom. People realized in the recent years that this was very important data if you want to understand, if you want to have the bigger picture about a huge sum of persons or actions, understanding not just the list of these persons, but their connections between them is very precious data. And again, 10 to 15 years ago, the mindset was not ready, I would argue, to consider these connections as worthy data. And as the two previous points argued, in any case, the storage capacity was not ready also to storage all this big information, all these big data sets about place, network interactions. And the last one I'd like to mention, free text, right? For example, 10 to 15 years ago, if you would like to save in your database what your customers think about your product, you would store, a rating from 0 to 5. You would have somebody to call your customers and ask them about their level of satisfaction, or you would just compute this number and store it. Now, free text, that is every blog, every comment that your customers made on blogs, everything that they discuss about your brand on Twitter, every phone conversation that you have with them is considered data in itself and can be stored and analyzed for that. And this is new, right? Free text until recently was considered too messy data and too complex to analyze and too big to store, so that it was discarded. So the fact, just to recap on this slide, the fact that information about people's location and movements, people's connections, and people free expression, the fact that all these things are considered as data has completely reshaped the meaning of data and the possibilities afforded by the analysis of a data set. It's much richer, of course, when you have the whole history of a person's location instead of just its place. You can make much more fine analysis. The slide mentions a couple of major actors in this domain, and I would encourage you to check them. Something that also characterizes big data is the fact that it's young, and expectations about big data are inflating. So to discuss that, I'd like to point you to the Gartner's hype cycle on the slide. Well, you could actually check on the internet what the Gartner's hype cycle is, because it does not just relate to big data. It's just a framework to analyze trends and how these trends evolve through time. Big data, as you can see from the slide, as analyzed by Gartner, is seen as being at the peak of inflated expectations. This means that, as for any technological trend, big data comes through different phases. When it just started 10 years ago, amounts of data were growing really, really fast. You had expectations coming from it. Analysts, business people, scientists, researchers, political analysts, everybody was starting imagining what these larger volumes of data would enable us to create. But that's very much in the imagination, because as long as big data has not been around for a couple of years or even a decade, you can't really know for sure what will be able to be done with that. So that's what this graph tries to express, that with time passing, you have first a technology that appears, or big data is not exactly a technology, it's a set of practices. When it appears, so that's the left of the graph, expectations start to grow about it. People start to fantasize about, well, the big bright world that big data will be able to create. And these expectations continue to inflate up to a point, and Gartner argues that we are at the peak of this of these expectations, up to a point where people get disappointed about the promises that big data was making, or that people around big data were making. When this peak is achieved, usually expectations deflate. People get disappointed, people start showing the bad and wrong and deceiving side of big data. And that works, I would like to insist, it works for any technological trend. Every technological trend goes through this peak of inflated expectations, and then, as they call it, the truth of disillusionment. And after that, maturity sets in, and the technological trend continues to evolve, but with reasonable expectations about it. So that's also what big data is about. Big data is also a lot about discourses about big data, and these discourses are sometimes plain optimistic, too optimistic, right? And we are in the middle of it as of 2014. So what are these big expectations that people talk about, that with big data, with this whole data that you have about everything, you will be able to detect things before they are reported. And you have a couple of, urban legends almost about that, such as, Google being able to detect flu before it's actually reported in hospitals, or how the LAPD police department is able to detect crime before it actually happens. Just on the basis for Google or for the LAPD, just on the basis of past data on epidemics or Google search queries or on crimes. The expectation is that, just like for epidemics or crimes or customer behavior, you will be able to have a complete view of the phenomenon that you describe, without any distortion, and you will be able to act on it as soon as you have the report ready. I like to insist this is the promise of big data. That's not that's something we have to practice by ourselves to make sure that these promises actually deliver. And finally, after these 4 points, I'd like to insist that the phenomenon of big data is still evolving. So we have phenomena that are just starting now, but that will completely renew or continue to expand the meaning of big data. The first of this phenomenon is the Internet of Things, or as it is called sometimes, the connected objects. With your toothbrush and car and light bulbs and aircon and shoes and whatever being connected to your Wi-Fi and to your central internet server, more data will be generated. So objects will create data about temperature, movement, light, whatever. And this is just starting. So in the coming years, we will see more and more products that are connected and generating data, and that will expand what big data is. The second movement that will continue expanding big data is the fact that data or stakeholders, private and public, tend to make more and more of their data open. This means that if data is completely hidden inside organizations, that's as much data you can't use if you're outside of these organizations. But major states and cities, NGOs, and even private companies make more and more of their data sets open, and that feeds into the larger pool of data available for analysis. And finally, something you might have heard of, the quantified self movement, which is again starting for a couple of years now, but really about to expand more. is the quantified self movement. The quantified self movement is the tendency that individuals have to track and measure their biological levels or their activity. You might have heard of the Nike Fuel Band or any other, or the Pulse, or any other device that tracks, and the number of kilometers or miles you run, or how much you weigh, or anything related to your daily activities. This is more data being generated, and what we can do with it is still not very well defined. So big data is going to evolve. This is about it, to have a very short intro about what big data is and where it's coming from. To continue on the topic, I'd like you to watch 2 other videos that focus on 2 terms that you often see discussed in relation to big data. This is the cloud and Hadoop. So please watch these 2 videos focusing on each of these terms, and continue the readings for week 1, which gives you real-life company stories and public stories and analysis about big data. Thank you.